Morning class. This is ECON 512 Introduction to International Trade class. Today is February 24th, Thursday. The class will review for the second midterm exam next Tuesday. So the exam will cover chapter 4, 5, and 6. Remember that in chapter 4, we discussed the Heckscher-Ohlin theorem. It's a basis of international trade analysis. In chapter 5, and we extend the analysis of Heckscher-Ohlin theorem in the international business cases. And in chapter 6, we analyzed the effect and costs and gains of tariffs. Tariffs are tax imposed by the government. So it's an import tax. So we are going to review and watch the video clips that we already discussed in classes. So let's watch the summary of chapter 4, 5, and 6 for the exam.
Now let's take a look at what the evidence says about the Heckscher-Ohlin theorem. But of course, you should be watching this in conjunction with our video on the Heckscher-Ohlin theorem itself. We're going back to the key question of what explains trade. And here we're talking about the quantity, the direction, and also the composition of that trade. One possible nomination for an explanatory factor about trade is factor intensities, namely whether your country has a lot of capital or a lot of labor relative to other countries in the world. So just to recap the Heckscher-Ohlin theorem, or HOT for short, it's saying that capital-intensive countries, by global standards that is, should be exporting capital-intensive products. Similarly, labor-intensive countries, again by global standards, should be exporting labor-intensive products. You can think of these propositions as a way of making the theory of comparative advantage just a little more concrete. So, for instance, if your country has a lot of capital relative to global standards, you might expect that, all other things being equal, that country will be very good at exporting capital-intensive products. In any case, that's the hypothesis which the Heckscher-Ohlin theorem is directing our attention to. But of course, we run up against that very tough question, is this actually true? Now enter Wassily Leontief, who later won a Nobel Prize in economics. He published a very famous paper in 1953, and in that paper he calculated the labor output and capital output ratios for a variety of sectors in the American economy. He also calculated how much capital and how much labor are embodied in exports. And here's the problem. By global standards, as you might expect, the United States measured as capital-intensive. Yet if you look at the content of American exports, in Leontief's paper he found that the U.S. exports on net labor-intensive goods, and it imports on net capital-intensive goods, and of course that's exactly the opposite of what the Heckscher-Ohlin theorem would lead you to believe. Actually, ever since Leontief's paper in the 1950s, the empirical status of Heckscher-Ohlin has been somewhat in a state of crisis. And so this is a puzzle which researchers have been trying to solve for the last 60 years. Another important test, again with largely negative results, came in a famous paper by Bowen, Lemur, and Svaikauskas published in 1987. they developed what is called the sign test. To do the sign test, you start by looking at a country's factor endowment. For instance, you might decide that a particular country is capital intensive. You then want to ask about the exports of that country. Will the exports of that country also be capital intensive? In essence, you're testing to see if you can find the same sign. Yet for that simple test, using global data, actually the Heckscher-Ohlin theorem fails at least 1/3 of the time. The authors also develop what is called the rank test. So let's say we look at a country which ranks, say, at number 3 when it comes to labor intensity of its factors. We would expect that same country, when you're looking at the factor content of its exports, to rank very high when it comes to labor intensity of exports. Yet in general, that is not the case. The rank order of factor intensity in a country does not very well predict the rank order of factor content in that country's exports. Instead, a country which ranks really high in terms of having a lot of labor will be exporting more capital in its goods than you might have otherwise tended to expect. Further empirical problems for the Heckscher-Ohlin theorem came out of a 1995 paper by Treffler called The Case of the Missing Trade and Other Mysteries. The missing trade puzzle is this. Given that there are big differences in factor endowments across countries, we should in fact expect to see much more trade than what we actually observe. Furthermore, the trade we do see on net doesn't actually send much embodied capital to the labor-intensive countries or much embodied labor to the capital-intensive countries, so there's hardly any trade in net factor content. I find this a very useful perspective. The observed deviations from Heckscher-Ohlin, you can read them as really asking, why isn't there in the global economy much more trade than what we observe? It's really a Coasian question about why are transactions costs so high and limiting what are potentially mutually beneficial exchanges. Another observed puzzle from the missing trade paper is this, namely that poor countries export less than is predicted by theory, and they import more than is predicted by theory. There's some difficulty in getting those countries to be viable sellers on a large scale, which our theory isn't quite picking up. So given all these problems, can we in fact save the Heckscher-Ohlin theorem when it comes to empirics? And it turns out there actually is a way forward which makes the theory more defensible. Let's go back to the original Leontief critique. Leontief classified the United States as capital intensive. But you might ask, well, who says the United States is in fact capital intensive? You can add up the labor in the United States and you can add up the capital, but what's the natural unit of measurement? You might argue that if the United States has different technologies than other countries, which indeed it does, well, we need to sum up labor in the United States to take account of the quality of labor in the United States, because the quality of labor is augmented by how much capital we have invested. So once we allow for different technologies, and once we allow for the fact that labor may be more effective in some countries than others, well, there exist measures that make the U.S. labor-intensive rather than capital-intensive, and then the Leontief paradox would go away, because we would be measuring the U.S. as labor-intensive and finding that U.S. exports are also labor-intensive. To go back to our video on the theory of Heckscher and Ohlin, keep in mind we really did assume a common technology across all countries. And when you have a common technology, it's relatively easy to add up which countries are labor-intensive or capital-intensive. But when that technology is varying, we then have to worry not just about the quantity of labor in a country, but how effective that labor is. There's even a way to make the Heckscher-Ohlin theorem a kind of tautology. If you observe that the United States is exporting labor-intensive goods, simply postulate that we have technologies so that when you combine them with labor, the degree of quote-unquote effective labor in this country is so high that we're actually labor-intensive after all. And indeed, there's an interesting test of the Heckscher-Ohlin theorem within a single country, looking only at regions of Japan, and of course within Japan, a relatively homogeneous country, you would expect technology across the different regions to be more or less constant. And what is it we find? Well, when technology is more or less uniform, the predictions of the Heckscher-Ohlin theorem do pretty well. And in fact, it's the capital-intensive regions of Japan which are exporting capital-intensive goods to other parts of Japan. Well, what to do? So there's now a whole new research program. What you can do is take observed Heckscher-Ohlin theorem violations, then see, given those violations, what is the implied difference in technologies across borders, and then you can do independent tests to see if these differences are in fact true. The original postulated version of the Heckscher-Ohlin theorem still is turning out to be false, but the theorem remains nonetheless useful. If you take the theorem and you modify the assumption of identical technologies, the combination of the theorem and an account of technological differences still will give you a kind of useful hammer for explaining some patterns of global trade. In this sense, the Heckscher-Ohlin research paradigm is alive and well. This point about technology differences directs our attention to a fundamental link between the Heckscher-Ohlin theorem and the lack of what is called factor price equalization across borders. That is, returns to capital and returns to labor do not equalize across borders, do not equalize across rich and poor countries. This, too, in part, is because countries have different technologies or maybe even different cultures. In this regard, you can think of a culture as a technology. So there's this fundamental factor, some kind of differences across countries which prevent perfect factor price equalization, and they prevent the Heckscher-Ohlin theorem from holding. And we're back to this basic fundamental philosophical question that we have two literatures on international trade, Heckscher-Ohlin theorem and factor price equalization, and they're both getting at what is basically the same question: how and why is it that countries are different, and how is it that those differences inhibit the amount of trade? The literature on the Heckscher-Ohlin theorem and related issues, of course, continues to grow. So some of the questions that people are working on now is trying to disaggregate the data better, so you're not just dealing with economy-wide or sector-wide measures of factor intensity, and also studying firm-level export decisions, again a move in the direction of greater disaggregation. The Heckscher-Ohlin theorem continues to generate fruitful puzzles for people to work on. This video already has listed plenty of sources and papers to read, but for overviews I found the following especially helpful. There's a paper by Heltman online called The Structure of Foreign Trade, and it provides an overview of some of these debates. The book by Robert Feenstra, Advanced International Trade, and the undergraduate text by Feenstra and Taylor give very good surveys on the Heckscher-Ohlin theorem. There's also a paper online by Davis and Weinstein called What Role for Empirics in International Trade? For closely related issues to Heckscher-Ohlin, see also our videos covering the topics of increasing returns and international trade, the gravity equation, and also factor price equalization. Now let's consider something called the gravity equation, and this is aimed toward trying to understand why the costs of trade are often so high. We have something called the gravity equation in physics, and this is stipulating, among other things, that the further away two objects are from each other, the weaker the attraction. For economics, our gravity equation is going to say the further away are two countries, the weaker the trade attraction. Now let's consider a very simple form of a gravity equation, just so you get a sense of how it works. On the left-hand side, we have trade, which is what we're trying to explain. That's the quantity of trade, and it's between nations I and nations J, as represented by the subscripts here. On the right-hand side, you can, in simple versions, treat this G as a simple constant. On top, you have M sub I times M sub J. Think of that as the size of one economy multiplied by the size of the other. So in general, in gravity equations, the larger the economies you're dealing with, the less distance is going to matter. And then on the bottom, we have D, the all-important distance, and that's the distance between country I and country J, again represented by the subscript here. As distance increases, trade does go down, but in more complicated forms of a gravity equation, this is often something exponential, so you could imagine it being d squared or d to the 1.25 or whatever, and those would indicate that as distance increases, the possibility of trade is increasingly decaying, the costs of trade are becoming increasingly larger at a faster rate. Empirically, consider this graph here. The horizontal axis is basically telling you how large a country is in economic terms. The vertical axis is basically telling you how much that country trades with the United States. As shown here, well, which are the two countries trading the most with the United States? There is Canada and there is Mexico. But if you ask how large are those economies, well, they're not especially large compared to a lot of other places. Why are they trading so much with the United States? Well, it seems at least one big reason is because they are so close. If you're wondering how gravity approaches fit into the broader picture of international trade, they are actually consistent with a lot of different international trade theories, such as increasing returns or the Heckscher-Ohlin theorem. So finding for the importance of gravity doesn't rule out the relevance of any of these theorems, but still it can be said to the extent that gravity theories of trade matter, that means an underlying model of international trade probably does require some specialization, because if trade costs are really that high, well, then you need specialization to be getting trade off the ground at all. And let's take a look at just how high the costs of trade seem to be in the gravity literature, and let's start with industrialized countries. To take one known estimate, again for developed nations, from Anderson and Wynkoop, the costs of trade across borders are on average about 170%. Of that sum, they estimate that about 21% is transportation costs, about 44% is border-related costs, having to deal with paperwork or bureaucracy or tariffs or different cultures or different regulatory standards. And indeed, breaking down that 44%, they find 8% a policy barrier, 7% a language barrier, 14% a different currency barrier, 6% an information cost barrier, 3% a security barrier. But again, these are just averages. These are examples giving you one way of thinking about where some of these gravity costs come from. Finally, again, according to Anderson and Wynkoop, 55% of that 170% is coming from retail and wholesale margins as trade crosses barriers. And by the way, if you're wondering how that all adds up, you can see it's given by this equation here. One quite striking result we learned from the gravity literature is that overall, tariffs are a relatively small barrier to trade, especially once we get past agriculture or outside of the very most protectionist countries such as North Korea. Overall, most of the costs of international trade come from other obstacles in having to cross borders. And you'll note those numbers come from developed countries, which on average tend to be more efficient and better at trading. For developing countries, trade costs can actually be at least 2 times higher. We also find empirically that trade costs vary with the product line, and they can vary by a factor of 10 or more. It really does depend what you're trading, and these numbers are just estimates, just averages. Early in this video, we offered a very simple form of a gravity equation, but actually the more accurate forms of gravity equation define distance costs relative to available alternatives. So let's consider a comparison here using data from the 1990s, and on one side of the comparison stands Australia and New Zealand, and on the other stands Austria and Portugal, both of course in Europe. Comparing these 4 nations, well, Australia and New Zealand are roughly the same distance apart as are Austria and Portugal. Furthermore, if you're taking the product of the size of the economies or the GDPs, again, this comparison you will get something pretty close to equality. And yet there's quite a striking truth here. In 1993, Australia-New Zealand trade is about 9 times greater than the trade between Portugal and Austria. Why is that? Well, Austria and Portugal are both located in Europe, and they have nearby a lot of other countries to trade with. Australia and New Zealand are much more isolated, relatively speaking, in the Pacific, and thus they end up trading much more with each other because they have fewer other natural trade partners. Here's the comparison. Let's take within the United States the average of state-to-state trade, and we're going to divide that by the average state-to-province trade, where by province we mean Canadian province, and on average that figure is about 1.5. So that means a given U.S. state is more likely to be trading with another U.S. state than with a Canadian province, but only by about 50%. From a Canadian perspective, a similar ratio will look quite different. So let's take the average province-to-province trade, and this is within Canada, and divide that by the average state, meaning U.S. state, to Canadian province trade. And there the ratio is much larger. It's quite striking. It's going to be 16.4 times higher. That is, a given Canadian province is way more likely to be trading with another Canadian province than with a U.S. state. But why are these two ratios so different? Consider some comparative statics. Say we start with a case where there are no costs of trade at all across borders, and then we introduce some kind of trade barrier which makes it harder to consummate these exchanges. As a result, both Canada and the United States would trade more with themselves, that is, they would trade more internally rather than exporting and importing, but in proportional terms, this is going to be a larger effect for the smaller, more open economy, namely Canada. This is part of a broader and more general truth that simply any increase in trade costs will have a larger impact on the smaller and more open countries. Let's think this through with a simple example using tourists. Here's the U.S.-Canada border as represented at Niagara Falls. Right now it's pretty easy to cross that border, but let's say it became a lot more difficult. The lines were longer, or a passport cost more to get, or security procedures would be tougher. How would this have differential effects on the United States and Canada? Well, the United States is a larger economic unit, so it's the case that in proportional terms we have more United States citizens taking their vacations already within the United States. So if passport costs go up, this has a moderate effect, but actually tourist sites in the United States do not become that much more crowded. Canada is a smaller and more open economy, so proportionally speaking, more of its citizens are traveling abroad. As passport costs go up, more of those citizens stay in Canada, and that will make Canadian tourist sites much more crowded. So here we have higher passport costs, meaning that Canada gets much more internal tourism, or you could say much more internal trade, and the higher passport costs mean the United States, the larger country economically speaking, is only getting a bit more internal tourism and a bit more internal trade. That's all just another way of thinking about how the gravity equation works. Another way to put this is simply to note that in more sophisticated forms of the gravity equation, relative trade barriers are what matter, not just absolute distance. For core readings on the gravity equation and how it's applied, I would very much recommend all of these sources, the bottom being you can simply Google gravity equation trade. Here are also some other reasons on the gravity equation approach. These are important articles, but they're also more technical or more difficult, and I would recommend them only to more advanced students of this topic. Now let's consider a proposition known as the Rybczynski theorem. The Rybczynski theorem basically asks, what happens if a factor of production increases in one country? For instance, imagine some labor migrating into a new country. The theorem says this: if the supply of labor increases in an economy, we then find that the output and exports of the labor-intensive sector go up. Perhaps a bit more counterintuitively, we also find that the output and exports of the capital-intensive sector will go down. Of course, that's for an increase in labor. If we did it for an increase in capital, we would find the output and exports of the capital-intensive sector go up, and the output and exports of the labor-intensive sector would go down. All of this is going to be based in Heckscher-Ohlin-like assumptions, and you can review those in our Heckscher-Ohlin videos. But basically we have a classic 2 by 2 by 2 model with 2 goods, 2 sectors, 2 factors of production, and 2 countries. In this context in particular, I would emphasize that we are dealing with an economically small country which does not influence world prices, so that is going to mean fixed prices for goods and also fixed prices for factors of production. Sometimes the theorem is presented graphically as follows. So on the vertical axis we have the production of computers, which is the capital-intensive good, and on the horizontal axis we have the production of shoes, which is the labor-intensive good. And we have 2 initial lines. This is called L1. This is called the labor constraint. It tells you how those outputs are constrained by the quantity of available labor. We have another line called the capital constraint. That's represented by C1 here. And if we take the labor constraint and the capital constraint, we find the economy is at this point, and this will imply an output of computers equal to this level and an output of shoes given by this level here. An exogenous increase in labor then shifts out the labor constraint to L2, so we then have this line here, which is out into the right of L1, and if we then combine the new labor constraint with the old capital constraint, we will find we are at this point of intersection. We'll have a new quantity of shoes here, and a new quantity of computers here, and if we compare the new and the old, what we can see is that output of shoes has gone up, and output of computers has gone down, and that is indeed illustrating the basic theorem. Alternatively, consider how this works in intuitive terms, so let's assume, for instance, that some new labor arrives in Guatemala. And now let's think through the steps. That new labor will mean a bigger boost to the production of labor-intensive goods, which in this case is shoes. That's because the more labor you have, well, that aids the production of things which require labor. But now think about it. Think about the ratio of capital to labor in shoe production. It's now the case that the marginal product of labor, the MP of labor, for shoe production, that goes down because we now have a higher ratio of labor to capital in shoe production, and the more labor you have relative to capital, well, that means a lower marginal product of labor, or at least that would be the case if factor prices were allowed to change. But now recall our assumption that the wage is fixed, in general prices are fixed, also the price of shoes is fixed, so prices cannot adjust, so we need in this model to be keeping the MPL, the marginal product of labor, equal to the wage. So how is it that we can get the marginal product of labor back up in the shoe sector? Well, what we need is that capital flows into the shoe sector to restore a capital to labor proportion, which will be consistent with keeping the marginal product of labor constant and keeping the wage constant. And so basically, capital is flowing into shoe production in Guatemala, and capital is flowing out of computer production in Guatemala, or whatever else is the capital-intensive industry. And because the capital-intensive industry is losing capital, we then conclude that output in the capital-intensive industry shrinks. And that gives rise to the basic results of the theorem. So just to review all of that, basically you are assuming prices are fixed because they're fixed in global markets, and we're talking about a small country here. There is then an exogenous shock. Consider that to be the arrival of either labor or capital. Since prices cannot adjust, then all of the adjustment has to be in quantities, which of course will include output. Furthermore, through a Heckscher-Ohlin mechanism, this will include exports too. So now that the country is more labor-intensive, they are more likely to be exporting labor-intensive goods. I would stress that the Rybczynski theorem is thought of as an abstract device or part of the economist's toolbox. It's not necessarily intended as realistic or representative, but it's a way of helping us think through the relationships between different quantities in an economic model, and of understanding the point that when economic prices cannot adjust, that in some manner quantities will adjust instead. Nonetheless, we can find some attempts to apply the theory to actual real-world phenomena, and most typically the theory is applied when we ask the question, will immigration lower wages? And the Rybczynski theorem actually is suggesting, at least if you buy into all of the assumptions, that immigration into a country will not lower wages or not lower wages very much. The adjustment will be in terms of quantities, and this will spur the production of labor-intensive goods, and again through Heckscher-Ohlin mechanisms, encourage that nation to become more of a labor-intensive exporter. For sources on this topic, there is of course the Feenstra and Taylor text. Check the index for the page numbers. You can simply use Google if you wish. And on the empirics, there's an interesting piece by Gordon Hanson and Matt Slaughter. Listed here, you can find this online.
Today we're going to look at the benefits of product variety and the effect of international trade on variety. People are different. Tastes differ. Even for a good as simple as peanut butter. Some people like crunchy peanut butter. Other people like it smooth. Some people like it salty. Other people prefer it sweet. We can think about welfare as declining the further away a good is from a person's tastes, in some kind of taste space. So more goods means that a person is more likely to find a good which is closer or closest to their particular type of taste. So variety can bring a lot of benefits. Of course, variety can sometimes also be a little bit confusing or overwhelming, especially if it's a good for which we don't care much about. Some people don't even care much about peanut butter, so the variety of peanut butter can be a little bit overwhelming. But usually, variety is a small price to pay in order to better match our taste with products. More products, more variety is also beneficial for producer goods, for intermediate goods. These are some goods from orthopedic surgery, for example. A long time ago, we used to just use, a hammer and chisel. Now we have more specialized, more designed goods, which are more specific and more tailored to a particular job, and that increases productivity. So more variety means closer to a person's tastes, and more variety means higher productivity for a particular task. So why can't consumers and producers have exactly their most desired good? The reason is that for many goods, there are economies of scale, and this means there's a trade-off between variety and average cost. So for many goods, the cost of producing the good falls the greater the number of goods which are produced. The cost per unit, or the average cost, falls the greater the quantity produced. So this means that if every individual had exactly the good which they most desired, the average cost would be very high. Instead, we accept a trade-off. We produce fewer varieties. Each one of those varieties we produce a greater quantity, pushing the average cost down. One of the great benefits of international trade is it makes the trade-off between variety and average cost easier to bear. We can get more variety at lower cost. I'm going to give a simple example from Militz and Treffler. Let's build this example with some assumptions. Suppose it takes 4 workers to design an automobile. And once designed, let's suppose it takes 1 worker to build an automobile. There are 2 countries, and each country has 12 workers. So let's look at one of these countries. It's got 12 workers. What are the things that country can produce? What are the production possibilities for the country with 12 workers? So, assume now there's no trade. Well, one thing a country could do is have 4 workers to design a single automobile, then have 8 workers producing automobiles, so you end up with 8 automobiles of one type of variety. Another thing you could do is to have 2 sets of 4 designers. Remember, it takes 4 workers to design an automobile. So that'll get you 2 designs. Then you've got 4 workers left over, so you can have 2 units of each designer, 2 units of 2 varieties. Okay. Now, what can we do with trade? Well, with trade, suppose we do the following. We now have we'll look at both countries. Let's suppose each country specializes. Country 1 has the green specialization, and therefore workers produce one variety, of which they then produce 8 units of that variety. The other, the blues, therefore workers design one variety, and they produce 8 units of that variety. So far it's the same situation as A, this situation here. But now with trade, suppose that they trade 4 units of one variety for 4 units of the other variety. What ends up to be the case then? Each country has 8 units of 2 varieties. So notice that with trade, the countries are better off. So compared to situation A, in which there was 8 units of one variety, each country now has 8 units of 2 varieties. Compared with situation B, in which there were 2 units of 2 varieties, that is 4 units overall, we now have 4 units of 2 varieties, that is 8 units overall. So we've got, compared to one situation, we've got more variety. Compared to the other situation, we've got more units. Either way, we are better off. Big advantage of international trade, increases variety. So I cheated a little bit on the last slide, and I want to say how. I showed you on the last slide that international trade could lead to a better trade-off between variety and average cost, could get us more variety at lower average cost. But I didn't provide a mechanism for how markets would make that happen. I didn't show you how the free market could or would lead to that particular outcome. And this turns out to be quite a difficult problem. So when lots of firms have these declining average cost curves, it turns out to be quite difficult to figure out how the market will trade off variety with average cost, how the market process will result in that particular outcome. There are, in fact, a variety of theories along these lines. All fall under the title of monopolistic competition. By the way, Paul Krugman, who did pioneering work in this area, sometimes it's said, well, what did Paul Krugman get the Nobel Prize for? And people say, well, he got it for showing that international trade also has the benefit of providing lots of variety. And people would say, well, what was so hard about that? Who didn't know that? You get more variety when you import goods. Well, that's only partially true. What he really did was to show how the economics of monopolistic competition would lead to a process such that international trade would generate you a better variety average cost trade-off. He explained how the market process would work. That turns out to be quite a difficult problem, which is why he got the Nobel Prize for it. The mathematics are quite complicated. I'm going to give you some of the intuition in a later slide. Here's another interesting point about globalization and variety. I've said that globalization increases variety, but actually globalization reduces geographic variety. More places start to look the same at the same time as it increases preference variety, or the variety actually available to individuals. Let's go back to our earlier example. Suppose we have no trade and we have these 2 countries. Well, now a traveler, a tourist, going from the green country to the blue country will say, look how different they do things here. They're blue here and my home country is green. And a blue traveler going to the green country will say, wow, look how different things are here. They've got green here. In my own country, they've got blue. But remember what trade does. With international trade, you've got a swap of blues and greens, and now a traveler going from one country to the other will say, well, they've got blues and greens here just like they have in my home country. So geographic variety declines. However, for people, for individuals, every individual in the world now has greater access to variety. And that's really what we care about. We care not that places are different, but that people have access to many different tastes and experiences. By the way, Tyler Cowen made this very clearly in his excellent book, In Praise of Commercial Culture. Tyler pointed out that what globalization does is it makes China, brings KFC to China at the same time as there are great Chinese restaurants in the United States. So China and the United States begin to look a little bit more similar, even though Chinese and Americans both benefit from globalization bringing greater variety to their countries. some estimates have been made of the benefits to increased variety, and they turn out to be quite substantial. So from 1972 to 2001, the number of product varieties imported into the United States increased by a factor of 3. And by one calculation, consumers would be willing to pay 2.6% of their income to buy in the larger 2001 supermarket than from the smaller 1972 supermarket. 2.6% of their income just from more variety. That's pretty big. And remember, increased variety also benefits producers by giving them access to tools which are more precisely tuned to exactly the job that they want to do. So it increases productivity. This has been less well estimated, but I think it's also important in my view. Okay, here's some further readings, most of which can easily be found on the web. This is Paul Krugman's 1979 piece, Increasing Returns, Monopolistic Competition in International Trade. It's the piece which made Krugman's reputation and was a foundation for a lot of his Nobel Prize work. An excellent review of some of this material is in Melitz and Daniel Treffler, Gains from Trade When Firms Matter. You can find that free on the web. It's from the Journal of Economic Perspectives. It's a very accessible paper. Estimating the gains from more product variety, Broda and Weinstein. Quite a difficult paper, but a worthwhile one to read. And of course, don't forget Tyler Cowen's excellent book, In Praise of Commercial Culture. Many good reasons to read that book. Thanks.
I'm back in my special shirt on location to talk about international trade. Before we talk about the costs of interfering with international trade, let's make sure we're clear on where the benefits from international trade come from. Let's look back at the graph that we used for a closed economy. Suppose we're in France and we're looking at the market for this product. Do you remember what it's called? That's right, it's a pomelo. We've got a supply curve for pomelos in France and a demand curve for pomelos that tell us how many pomelos the French people want to buy at different prices. Now, if we have a closed market for pomelos, the equilibrium point will be where the supply curve and the demand curve intersect. Here's the price, P star in equilibrium. Here's the quantity, Q star in equilibrium. Well, how much economic value is created in this market? Can you identify the consumer surplus? The consumer surplus is the area above P star and below the demand curve. Where's the producer surplus? The producer surplus is the area below P star and above the blue supply curve. The total economic value created in a closed economy is the area between the demand curve, which represents economic benefit, and above the supply curve, which represents economic cost. Between these two curves is the difference between benefit and cost, or economic value, for this entire market. Suppose now that we introduce international trade. And in the case of the pomelo, we're going to allow France to import this fruit at a lower price from the rest of the world, from outside the market. So let's put in the lower price for pomelos, P sub W, and at this lower price, people in France can buy as many pomelos as they want, and farmers in France can only charge this price if they produce pomelos domestically. With international trade, we think of the red curve as domestic demand, the blue curve as domestic supply, or the cost of producing pomelos domestically. And we realize that all trades that take place have to take place at the world price, PW, because no customer is going to pay a higher price when they can import the good at a lower price from somewhere else. That means the farmers in France cannot charge a higher price. They must charge the world price. At this lower world price, how much consumer surplus is created? See if you can identify the area that represents total consumer surplus when people in France can import pomelos at this low world price. In order to identify the total amount of consumer surplus created, start by finding the total quantity of pomelos demanded at the world price. That's going to be following PW over to the demand curve. Here's the quantity demanded domestically. With people buying this large quantity of pomelos at the price PW, consumer surplus is now the area underneath the demand curve and above PW. That is, it's this entire big triangle. How much producer surplus is now available with international trade? To calculate the total amount of producer surplus, follow PW over to the supply curve to remind yourself what the quantity supplied domestically is. Producers are able to charge PW, and their costs are represented by the height of the blue line, the supply curve. Producer surplus with international trade will be this small triangle that is below the world price and above the cost of making pomelos domestically. What is the total amount of economic value created in this market when international trade is available? It will be the sum of the consumer surplus, this large triangle, and the small triangle of producer surplus. Now, here's a question. Has the total amount of economic value increased because of international trade, or has it not increased? The answer is it has increased, and let's see if we can show why. First of all, notice that as the price falls from P star to PW, as the import opportunity lowers the price of pomelos, the amount of producer surplus created in France for the producers of pomelos domestically, that quantity shrinks, and it shrinks by the amount of this rectangle. The lower price means that a lot of producers in France are going to drop out of the market for pomelos. They're no longer going to produce them. So we have a shrinkage of domestic supply, a reduction in the quantity supplied domestically. Also, because the price is lower, even those farmers that are still in the market, still able to produce pomelos, are earning less revenue. They're making less money. Instead of earning this large price for pomelos, they're getting a small price. So there is a smaller amount of surplus for them, even on the pomelos they're still making. So this entire trapezoid, this area right here, is producer surplus that is no longer available. That is, producer surplus that has been destroyed for French farmers by the fact that imports are now replacing their business. However, the amount of consumer surplus that's created is this very large trapezoid. With the lower price, consumers are ecstatic because they're getting a great bargain, and a lot of consumers are now going to buy pomelos who couldn't afford them or chose not to buy them before. Not only are more customers in the market for pomelos, but even those customers that were buying pomelos at the high price, they're even getting an extra advantage because they're able to get their pomelos at a discount. That is, the price is falling, adding to their consumer surplus. The total increase in consumer surplus is this large trapezoid here. Notice, the large trapezoid, which represents the increased consumer surplus, completely offsets the loss of producer surplus. That is, this small trapezoid lies entirely within the big trapezoid. The net gain for the economy in France, the net gain is the area of this triangle, the triangle that's below the old equilibrium down to the import price. You can think of this triangle as equal to the quantity of imports multiplied by the difference between the old price and the new price, multiplied by 1/2. That is, this rectangle represents the gains from trade. The difference between the additional consumer surplus, or the benefit that consumers get from buying low-price pomelos, and the loss to producers of losing a market. If you subtract the lost producer surplus from the gain in consumer surplus, you get the gain from trade. That is what's left over. And it's always going to be positive.
Let's look at a brief history of just how much the shipping container has boosted world trade. What we've learned from studying the data is just how much the shipping container was a big breakthrough, arguably the big breakthrough, in the post-World War II expansion of global trade. This is a technological innovation which consumers generally do not handle directly, and probably they don't think very much about, but it really has been quite significant. A key feature of the shipping container is not just the container itself, but its standardization. It's made it possible to have standard operating procedures for loading materials on and off of boats, running ports, and facilitating logistics, and this has made trade much easier to handle. The hard part about a lot of international trade is not shipping the goods across the ocean, but rather processing them when they're being packed up and processing them again when they're being unloaded. A big part of the gains from shipping containers have been their ability to support and induce a coordinated system involving cranes, ports, and storage, again with this key property of standardization, making it much easier to load and unload goods. A primary entrepreneur behind shipping containers, by the way, was an American, Malcolm McLean. He was a trucking magnate, and he first tried out the idea in 1956. Prior to shipping containers, which allowed for standardization and also machine-operated ports to a greater degree, a lot of the loading and unloading was done by dock workers. That cost a lot of money, and it also involved a lot of management problems and coordination and information problems as well. You don't actually see many workers in this picture, and today, quite often, a port is a pretty quiet place. This whole idea spread pretty rapidly and pretty fundamentally. So in 1966, just 1% of all countries had ports which could handle shipping containers. By 1983, that had gone up to about 90%. And it's astonishing how much port labor productivity rose in places where shipping containers were instituted. So for instance, in 1965, we have measurements of port labor productivity being 1.7 tons per hour. By 1970, a mere 5 years later, we have measurements where port labor productivity is about 30 tons per hour. Of course, that's a very significant increase. The best numerical estimate we have looks at 22 industrialized countries and finds that shipping containers explain a 790% of increase in trade over the first 20 years of their use. That estimate is found by comparing places which had introduced shipping containers and what their growth in trade was as compared to places which didn't, or which did only later on. And even if that's an estimate on the high side, scholars are in general agreed that the technology of shipping containers has driven a much bigger increase than, say, bilateral free trade agreements. And according to the same measurements, those bilateral free trade agreements would account for a 45% increase in world trade over that same period. And of course, that's a much smaller growth than what we've gotten from the shipping containers. Above all, I think of the shipping container story as a tale of just how subtle and indirect and maybe hard to observe important innovations can be. Anyway, for sources to read more, there's a very good piece in the magazine The Economist. This should be online. The main empirical results discussed here are taken from this paper, which is a working paper on shipping containers. There's a whole book, very good to read, by Mark Levinson. It's called The Box. It's basically the history of the shipping container. And not so much on shipping containers, but on trade and transport costs more generally, I would recommend this piece by David Hummels, and that's available online. Now let's look at the evidence on how much the idea of increasing returns explains the content and structure of world trade. Just to review, the notion of increasing returns to scale suggests that something gets cheaper at the margin as you do more of it. This can be applied to the level of the firm, to the industry, or even a geographic region. And again, here we're comparing a factor endowments view to an IRS, or increasing returns to scale view. The factor endowments view is saying that a region has some significant advantage accumulated ex ante, such as having a lot of labor, which then makes it easier to export goods which are produced by a lot of labor. The increasing returns to scale stories are more of an ex post view, that is, you end up being good at something because you started doing that. Note that the increasing returns to scale view in general will require some extent of market or monopoly power, whereas the factor endowments view can be made consistent with either perfect competition or market power. We can look at possible predictions of increasing returns to scale theories in 6 different areas. The first is intra-industry trade. There's then the fact that similar countries tend to trade a lot with each other, that the gravity equation fits the data well, looking at firm-level evidence, whether or not there is a home market effect, and finally the issue of path dependence in response to shocks. By the way, for much of the structure of this discussion, I'm relying on an online handout from David Donaldson at MIT, which you can find online here. Let's first consider intra-industry trade. For instance, you can imagine that Great Britain is selling, say, white shirts to India, and India is in turn selling colored or flowered shirts to Great Britain. You might think that each country has simply specialized in one kind of shirt, and it would seem that differing factor intensities are not explaining the fact that there is trade in shirts running both ways. But over time, the Heckscher-Ohlin or factor intensity theories, they made a comeback on this point. If you develop a Heckscher-Ohlin theory, but you allow the two countries to have different technologies, then you can, in fact, within a factor intensities framework, get this two-way trade across nations within a given sector. Intra-industry trade may also be the result of factors which are neither increasing returns to scale nor factor intensities, and in general on this whole point, there's a very good article by Donald Davis. Similar countries trade a lot with each other, such as the United States and Canada pictured here. At first glance, this would appear to be inconsistent with a factor intensities approach, because the factor intensities approach at least appears to suggest you get a lot of trade when the countries are very different. But again, if you modify the assumption of an identical technology within the factor intensities approach, it turns out that that too is quite consistent with the notion of similar countries trading a lot with each other. And on this point, do see our videos on the Heckscher-Ohlin theorem. The so-called gravity equation seems to explain a great deal, and some economists believe that this is more readily compatible with an increasing returns to scale approach than with an approach which emphasizes factor intensities. To the extent that trade across great distances really is costly, you might think, well, this requires some strongly differentiated products to get that trade off the ground. But again, while this evidence is certainly consistent with increasing returns to scale theories, it's also consistent with the Heckscher-Ohlin theorem and factor intensity approaches, where you have factor endowments driving specialization. To sum up these first 3 areas in maybe a single point, what we're seeing in the data is very strong evidence for specialization, but specialization here is the key, and specialization is not identical with increasing returns to scale. You can get specialization also from factor intensity approaches, again relaxing this assumption of identical technologies. There's a fourth source of evidence on behalf of increasing returns to scale theories, and this is somewhat more illustrative, and that is what is called firm-level evidence. So rather than looking at different industries or sectors, let's look at the behavior of individual firms, and we find a number of results which appear to suggest that in the arena of international trade, there's a lot of market power. So for instance, markups are falling with foreign competition, import competing firms are cutting back their production when foreign competition goes up, and all in all, when you look at the entire package of propositions you see about individual firm behavior, this does seem to be fairly compatible with a model of monopolistic competition and differentiated products. Perhaps the most convincing piece of evidence from my point of view is the literature on what are called home market effects. And that literature suggests that countries which have a large home market for a good are also the countries which tend to export that good. Think of that large home market as having given the country a start in an area, and then because of increasing returns at either the firm or the industry level, well, the country becomes better and better at producing that good or service, and that eventually leads to export success. A simple example is that both Hollywood and Bollywood have large domestic markets for movies, and they have ended up being very successful exporters. The French at home drink a lot of wine, and they've ended up being fairly successful at exporting that wine. If you go to Germany, you'll see a lot of fancy kitchen stores with really sharp knives. And again, Germany has become a successful exporter in that area. The large home market effect is by no means always present, but we do see it a lot in the data, and I would recommend you take a look at these two pieces, both available online. Yet another way to think about increasing returns to scale theories is to ask questions about path dependence. So for instance, do regions get nudged off increasing returns to scale paths, or do they bounce back? If you view productive success as being the result of basic fundamental endowments which are not going away, you would think that if a country or region gets nudged off a path, it will end up mean reverting and getting back on that same production path. Alternatively, if you think it's a matter of accumulated experience based only on some very small initial advantage, you might think it's easier for a region or sector to get nudged off its path of success. If we look at cities which have been bombed, it seems that over time they revert back to where they would have been had the bombing not occurred, at least in terms of overall economic activity. So today in Japan, both Hiroshima and Nagasaki are fairly successful, fairly productive cities. It seems they had good factor endowments, and they managed to keep that advantage and then rebuild. The point that urban bombing shows a lot of mean reversion, and thus to some extent supports factor endowment theories, you'll see that discussed and illustrated in these pieces here. In other areas of urban history, we find examples where that initial nudge really seems to matter, and the importance of that nudge seems to persist. Memphis became a major American city at first because of its location on the Mississippi River. That location is no longer so important, but Memphis remains important as a city in Tennessee to this day, in part because it had such a significant early head start. On these nudge effects for cities, you should read Bleakley and Lynn, Portage and Path Dependence. One thing that's interesting about these urban literatures and these urban examples is that you're starting to see ways in which trade theory and economic geography, or location theory, actually overlap quite closely. So to sum up, it seems that increasing returns definitely matter for explaining international trade. There are some areas where there appears to be an observational equivalence between increasing returns theories and factor endowment theories, so we're still not sure how much, but pretty much everyone agrees increasing returns are a very important idea for explaining the structure and content of cross-national and cross-regional trade. In this unit, we're going to unlearn two myths about multinational corporations. Maybe these aren't myths that you yourself believe, but still it might be useful to set out more explicitly exactly why they're wrong. Sometimes it's argued that the very largest multinational corporations are much bigger than countries. Let's see how this argument goes. Well, if we take the company of Apple, right now, as of mid-2012, their market capitalization is somewhat over $500 billion, which of course is a very large sum. Apple is a large company, and right now they're the largest company in the United States and the largest real private sector company in the world. But here's where the mistake comes in. You could take some countries that have GDPs of at or a bit below 500 billion, and those countries would include Poland, Belgium, Sweden, Switzerland, and people are sometimes tempted to conclude that Apple, as an economic entity, is larger or more important than those countries because the market capitalization of Apple, somewhat over $500 billion, is greater than a lot of those GDPs. But that is a mistake. It's a mistake because it's confusing stocks and flows. GDP is essentially a flow. It's the value of goods and services produced in a year in a given country. So very roughly you can think of GDP as something happening at a particular point in time, a stream of goods and services. Capitalization of a company is a stock. It's the expectations about the total amount of value embedded in that country across many future years. So if Apple has a market capitalization of about $500 billion, well, that's the stock. The flow of sales through Apple in, say, 2011, that was a little bit over $100 billion. That's still very large, but you can see that for Apple, the flow is much less than the stock, just as in this picture, the flow of water is much less than the body of water, which you can think of as the stock. So if you're comparing the capitalization of a company to the GDP of a country, you are in essence confusing stocks and flows. It should not come as a surprise that in many instances the stock will be measured as larger than the flow, but that doesn't mean that Apple as an economic entity is more important than, say, Belgium or Sweden. Our second issue is quite distinct. This comes up when you find individuals in very poor countries who are working in the factories of multinationals. It may be the case that many of these individuals are paid no more than a few dollars a day. Observers look at these situations and very frequently they call it exploitation. That you could have a multinational company which is so wealthy and perhaps so profitable and it's paying its workers such small amounts. Now this is very often a moral argument, and economics per se cannot evaluate moral arguments, whether they're right or wrong. But nonetheless, understanding the world through an economic lens can help you frame moral arguments in different ways. So the original view was that the multinational corporation is exploiting the poor worker by paying that worker just a few dollars a day. An alternative view, suggested by economic reasoning, is to wonder if there is exploitation in this situation. Maybe the problem isn't the company paying the worker, but perhaps the problem is that there aren't more companies paying the workers. Let's look at this in more detail. If you look at the nation of Singapore, in the 1960s, Singapore was not a wealthy place. Its workers were paid very small sums of money, and sometimes the workers were paid small sums of money by multinational corporations. Nonetheless, the leadership of Singapore decided that it would open up the country to foreign investment and protect the rights of foreign investors and create a favorable tax and regulatory environment. And over the next few decades, there was a lot more foreign investment in Singapore. What happened to all that exploitation? Well, it went away. Today, Singapore is an extremely wealthy place, and in fact, in terms of per capita income, Singapore is now wealthier than the United States. Looking at Singapore helps us shift our perspective. The exploitation problem is not the foreign investors you have. If there is an exploitation problem, you can think of it in terms of the foreign investors you do not have. Or let's look at an area where multinational investors have gone away. In the country of Haiti, there is a town, Jérémie, on this part right near the water on the northern coast. And in former times, Jérémie was well known for attracting a lot of foreign investment and some factories run by multinationals, including Walt Disney. These factories paid low wages, but still an awful lot of Haitians were quite happy to work there because it was higher wages than they could earn on their own. Unfortunately, over time, most of these factories went away. The Haitians had a good reputation as workers, but there were problems with the electricity, problems with political order, problems with corruption at the port, and in general, Haiti, over considerable periods of time, was becoming a poorer country and a less well-run country. So the multinationals leave this part of Haiti, and over time, what can we say? Well, maybe you could say the exploitation went away, but is that really the correct way to think about it? The developmental path of Jérémie would have been much brighter if over the last few decades it had been gaining multinational investors